This video is all about showing you how to host your own dedicated PalWorld server on Amazon Web Services or AWS. Maybe you want to run your own dedicated PalWorld server so that all your friends can join in and play, but your home network or your computer, they're just not reliable or powerful enough to do so. So you go to Nitrado or some other server hosting company and you rent a PalWorld server from them. But over the course of playing, you realize you want more control. For some people, they're fine with the amount of control that these dedicated hosting platforms give them, but others want full control. They really want to be able to dig into that operating system. Now, if you're new to AWS, don't worry. This video is designed for both beginners and people who do have experience with AWS. I'll show you how to create an AWS account, and we're going to use a Terraform module that I've published to create our PalWorld server and infrastructure and install PalWorld. And Terraform is an infrastructure as code tool where we describe how we want to deploy our server and all the resources instead of clicking through the UI and saying, I want a server and I want it configured like this. We describe it as code and we deploy it that way. Now, I can already hear the people in the comments saying, why would you run this on Amazon Web Services? It's too expensive.
I am never going to financially recover from this
when compared to a game hosting platform like Nitrado or some other platform. And to that, I would say you are correct. If you leave the server, the actual physical server that we're going to create running 24 hours a day, 7 days a week, it will be more than a hosting platform like Nitrado or some other platform. However, we can reduce these costs, and if you manage them properly, it can actually be cheaper than those hosting platforms. So if you stay tuned to the end of the video, I'm going to go over some cost-saving tips, how we can automatically start and stop our instance when we're maybe not using it, and how we can set up cost budget alerts so that if our budget is expected to go over budget, we can get an email and be alerted to that. So obviously the first thing we need is an AWS account. So if we go to Google and we just simply type in sign up for AWS, the first link it brings us to is sign up for a free AWS account. And then once we're there, we're going to hit create a free account. Now, AWS accounts are free by their nature. They have what's called a free tier in which you can use certain things for a specified period of time. And when that time expires, it is no longer free. But while you're in that free tier trial, you can use things that are outside of the free tier and you'll begin to incur a cost. And it should be noted that when we run PalWorld, in order to run a powerful enough server, we won't be dealing with the free tier. So you will need a credit card of some sort in order to begin using AWS for PalWorld. Go ahead and fill in these boxes, follow along with all of the prompts. It should take you anywhere from 5 to 10 minutes. You will need a valid credit card and your address, phone number, and email address. And here's where they ask you for your billing information, and this is required. Note, they will not charge you for usage of AWS free tier limits, right? If you stick within those limits, you won't get charged, but for our purposes, we will be exceeding those limits, so we will be getting charged. So you will have to provide this here. Once you get to the point after you've confirmed your identity, it says sign up for AWS, you pick a support plan. We don't need developer or business support. We'll do basic support, and then we'll hit complete sign up. Once you're logged into your AWS account, you'll see this services tab up here on the left, and this is a list of all the services that we can use within AWS. We will be primarily focusing on EC2, S3, and IAM for the purposes of this video. If you feel like going through here and exploring, feel free, but let's move on to installing the other piece we need for the video, and that is Terraform. Now you can simply Google install Terraform and you'll probably get these two links. So this one, install Terraform, leads to the tutorials section of the HashiCorp docs. And this one brings you to the actual page where you can download the packages. So if you click on this first one, you get a small video on how to download and install Terraform. And then they have a little tutorial that you can follow. You pick your operating system. Are you on Windows, Linux, manual installation? And then that second link, install Terraform, and I'll put a link to both of these in the description. This has all of the packages so you can download and install them manually, and that's what we're going to do. So if you're on Linux, you probably know how to use your package manager. If you're on Ubuntu, just follow these instructions. If you're on Red Hat, CentOS, right, to install Terraform, pretty simple. If you're on Windows, it gets a little more complicated. Now, I'll be doing this on Windows because I expect most people watching this video are new to Terraform and running that from Windows. So we'll start with that. So again, I'll put the link in the description, but we're going to go to the Windows binary download, and we're going to go to AMD 64, unless you are on a 386 architecture system, but 99% of you are on AMD 64 systems, and we'll hit download. So you should have this .zip file in your downloads folder or wherever you downloaded it to. Go ahead and open that up, and we need to extract this to our computer somewhere. So I put mine in the F drive. I have a folder labeled Terraform, and that is where I put all of my Terraform executables. But you can put it anywhere on your computer. Now the second thing I have to do is I have to tell Windows where Terraform is, the path on the computer to the Terraform executable. So to do that, we'll simply search for environment variables, and we'll hit edit system environment variables. And that'll open this window here, and we'll simply go to environment variables, and then under user variables, we will go to path, open that up, and we will simply add the path to the Terraform executable. So you can hit new, and then wherever on your computer it exists, right? If it's on your C drive, Terraform folder, you would do that. And so now when you run the Terraform command, Terraform will look through all of these paths and say which one contains Terraform.exe, and it will run it from there. So you can see I've already configured the path F drive /Terraform folder because that is the folder that Terraform.exe is in on my computer. So then you can hit OK, OK, and OK. And now to test it, you can open command prompt or PowerShell, and you can simply type Terraform -- version, and that should return a valid Terraform version. And so you've successfully installed Terraform on Windows. So now that we've got everything we need to start deploying our PalWorld server on Terraform, real quick, tell me you're using Visual Studio Code. It is an IDE, integrated development environment. If you don't have it, highly suggest you download it and install it. It's not needed for this video, but if you're into this kind of stuff, cloud, Terraform, code, software engineering, right? You're going to want Visual Studio Code. So the first thing we need to do is we need to create like our working environment, right? We're going to be running Terraform from a folder or directory. So we need a place to create Terraform configuration files and run Terraform from. So I've created on my desktop this PalWorld Terraform folder. It can be anywhere on your computer, doesn't really matter. And this is going to be my working directory where I'm going to create my Terraform files and run Terraform from. So if you're not interested in using Visual Studio Code, right, you could simply just open PowerShell and go to this directory, and you could work from here. It's the same thing. But for those of you who like making life easier and you have Visual Studio Code installed, we're going to go to Open Folder, and we're going to go to that folder that we created, and we're going to hit Select Folder. And so now we're in that folder, but in Visual Studio Code. So over here on the left, inside the folder, right, we're going to click, we're going to create new file, and we're going to call it main.tf. Now, we're beginning to write our Terraform code. So what we're going to be using is what's called a Terraform module. So the first place we're going to start, and I'll leave a link in the description, is this Terraform module that I have written real quick. What's a Terraform module? Well, a module in Terraform is essentially a piece of code or a configuration of Terraform code that you've written and then packaged it and published it to what we call this Terraform registry. So if I go to browse modules, right, there's modules for all sorts of things. People have already written it. So I don't have to go back and write it myself when I want to do it. I just use somebody else's module. You can think of this as like a Python package or a Go package, right? Somebody's written it. I'm just going to download it and provide whatever inputs they've made available. So if you look at this module page here, and again, I'll leave a link in the description, we've got a README, and this comes from the GitHub README with some instructions on how to use this. We've got inputs. These are the available inputs you can provide to the module. Outputs, the available outputs it will give you, any dependencies, and any of the resources that could potentially be created by this module. There's a source code link here, and if I click that, it brings me to the actual code for this Terraform module. And the README is here as well, and the README in GitHub actually renders pictures, so if you're going to follow along with the README, I'd suggest you go to the GitHub page. There's also some examples in here, so if you click on the examples folder, these are examples of using Palworld in different scenarios. Do you want to enable backups? What does that look like? Do you want to bring an existing PalWorldSettings.ini file from an existing server? What does that look like? Restore from backup, right? You've got existing game save files and you want to migrate from one server to this server. There's ways to do that, right? So if we click on this vanilla Palworld example, you can look at the README, and these are the relevant inputs. There's some example files here, right? If you were going to use this module as an example, what would it look like? Just make sure you change the source. We'll go over that in a minute. So back on the module page, over here on the right where it says provision instructions, we're going to copy that. And over here in our main.tf, we're going to paste that there. And so this is telling Terraform we would like to use a module, and we're going to call it Palworld, and this is where we're going to get the module from. And this is the version of that module we want, because you can call a specific version, or you can even do like greater than equal to, or you can even remove it because it's not required. And then in here, within these squiggly brackets in this module block, we need to define our inputs. So back here, these are our available inputs, right? This is everything you can pass. And you'll see each one of these has a description about what it is and a default value. So if you don't specify an input, right, you don't have to specify all 91 inputs. You only need to specify the ones you care about. And if you don't provide them, then the default will be used. So for instance, this Palworld setting collection drop rate, you can specify this input, set it to 2, and it will use that one. But if you don't, it will just keep it as 1. And if you look at the README and you scroll all the way down, there's actually a section called inputs that has more detailed information in a more, shall we say, eye-pleasing format on what each one of these inputs does. So I'm going to go to examples, and we're going to do vanilla Palworld with default settings. And I'm just going to copy all of these inputs. And then I'm going to go back to my main.tf file, and in the module block, I'm going to paste all of those. Now, we're not going to go and edit every single input. That would take way too much time, but I'm just going to go over the important ones, and we're going to change a few. And then we're going to get our server up and running. So instance type, this is the type of AWS instance you would like to use. There's a lot of them. There's a lot of different configurations. This specific one, T3 extra large, it is going to run you anywhere from $3 to $4 a day. This is the most expensive part of this entire thing, is the actual server. The larger it is and the longer it runs, the more money it costs. If you're not using the server, you can turn it off, and that won't cost you any money. Stay tuned to the end of the video, and I'll show you how to save some money and how to set up budgets. This particular instance type is what we call a burstable instance. It's 4 CPU cores, 16 gigabytes of RAM. So I'm going to leave this T3 extra large for now, because the Palworld technical docs, if we can call them that, say they recommend at least 16 to 32 gigs of RAM. Create SSH key. We're going to leave this true, and I'm going to show you how to create an SSH key right now. And then we're going to have to provide the SSH key public path that we create. And this is going to upload our SSH public key to the server so that when it's created, we can get into it to look at what's going on and to troubleshoot. To create an SSH key pair, if you're using Visual Studio Code, you can just go up here to Terminal, hit New Terminal, and that's going to open a PowerShell window down here at the bottom. And we're just going to use the SSH-keygen command. and it's going to prompt us for the name of the key, and I'm just going to call it PalWorld. Not going to give it a passphrase, and that's it. And you'll see over here on the left, it has created these keys inside of this folder here. Now, if you're following along with the video, but you're not using Visual Studio Code, you can just open like Command Prompt or PowerShell, and the same command will work from there as well, right? So if you're not using Visual Studio Code, it's still possible. So with my SSH key created, I need to provide the path relative to this working directory. So relative to the folder that I'm in, the path to this file. So since the file is in the same folder, all I need to do is provide palworld.pub. And so when the server gets created, it's going to upload this key to the server, and then I'll use this one, the private key, to connect to that server. So public key gets put on server, I use private key to connect to server. So on to the PalWorld settings. So before we move on to these, right, basically anything you provide here is going to end up in PalWorldSettings.ini. Now, if you also use this input, use custom PalWorld settings, that file and those settings will be used, and all of these will be ignored. So just keep that in mind. You can't use a custom ini file and also edit these and expect these to overwrite your file. It's not going to work. So real quick, we're just going to edit some things here. So let's speed up the daytime speed. Let's increase the EXP rate. You can change the death penalty if you want. Let's turn on friendly fire. I'll take one of those. I'll take one of these. Let's make sure we give our server a name that means something to us. So let's just call it AWS PalWorld Test. And we can give it a server description. I'm just going to leave it alone. And now admin password. So this is going to be the password required to actually use like admin commands in game and connect with Archon if you enable Archon. Public IP, you don't have to fill it in. You can if you want to. And then region, also you don't have to fill it in, but you can if you want to. Now there's one more file I want to create, and that has to do with outputs. And now we don't need this in order for this to work, but it makes our life easier. So I have created this module to output 5 things when it's finished running, some information. And one of those things is actually the public IP. So after it gets created, it'll spit out the public IP, so then we can use that to connect in the event we can't find our server in the server list. But in order for this to work, we have to come over here to our Terraform working directory, and we have to create a file called outputs.tf. And if I didn't mention it before, Terraform files end in the extension .tf. It doesn't matter what you name these files as long as they end in .tf, but I am using the best practices naming convention that I recommend you use if you're getting into writing Terraform. So I'm going to take these outputs actually from, if I go to the source code for this module and I go to examples and I go to vanilla PalWorld settings and I look at outputs.tf, I'm actually going to just copy these and I'm going to paste them in there. All right, so now that we have created our Terraform configuration and we have an AWS account, the last step to getting this all work and tie it all together is we need to tell Terraform how to connect or authenticate to our AWS account. So this video is by no means here to teach you how to become a Terraform expert or an AWS expert. I am just giving you the basic tools needed to do what we need to do for this video. So Terraform has a concept of providers, and a provider is essentially how you tell Terraform to connect to whatever you're attempting to create something in. And we are attempting to create things in AWS, so we need the AWS provider. Now the module requires the AWS provider, so when we run Terraform, it will download it and use it, but we have to tell the provider how to connect to AWS, which means we have to basically give it a username and password of some sort. So in order to do this, log into your AWS account and go to IAM, the IAM service. Now, if you're logged in as the root account, and if you just created your account, you probably are logged in as the root account. You'll see these security recommendations that you should deactivate or delete access keys for the root user. Now, I'm not here to teach you how to be an AWS expert, but you should know that it is best practice to come over here to users and create another user and then log out of the root user, log in as that new user, and use their access keys. Because if you're going to use the root access keys, right, then if somebody gets access to those, if you accidentally upload those to GitHub, then someone gets access to your entire AWS account. Whereas if you were to create a user and give them only the permissions they need, if someone got those access keys, they would have a very limited ability to do damage to your account. So for the purposes of this video, because this is meant to be beginner friendly, I am not going to create a user and go through that whole process. You're going to log in as the root account, or if you're experienced, log in as a user with the correct permissions, and you're going to go to manage access keys. And you're going to see a section called access keys here. Now you shouldn't have any access keys, or you might have like one set of access keys, but you should be able to click on the create access keys button over here on the right. And when you click create access key, it's going to ask you if you understand. And again, you're going to get the warning about the root user key. And it's going to give you that access key and a secret access key. So this is essentially your username and this is your password. So go ahead and copy these, put them somewhere safe, and then you can go ahead and hit done. So now we have to give Terraform this access key and secret key so that it can connect. So the AWS provider, we can hard code these credentials into a provider block, although that's not recommended because if we accidentally put this code somewhere, say GitHub, now someone has access to this key. And so you see where the danger lies in using those root access keys. The way we're going to do it for this video is we're going to set environment variables. So if you're on Linux, all you need to do is copy these commands and then change these values to use your AWS region, your access key, and your key ID. And real quick, if I didn't explain what a region was yet, in AWS on the top right, you'll see like North Virginia or some other region. This is what they mean by region. So depending on where you want to deploy your server, right? If you live in Europe, you're going to want to deploy a server in Europe, not US East 1. Now, if you're on Windows, this command, you're not going to be able to copy and paste it. We've got to set the environment variables, and that's different when it comes to Windows if you're using PowerShell or command prompt. So back in VS Code, I'm going to open a new terminal again. This is going to open up my PowerShell command prompt. And just like all the times before, you don't need Visual Studio Code to do this. You can simply just open a PowerShell window, and that's the same thing as this terminal here. So the equivalent command in PowerShell to those export commands would be, and I'm just going to open a new file right here and call it temp, this command here. So $env : and then our environment variable and the value. So go ahead and take that access key ID and that secret access key and the region you would like to deploy into and go ahead and modify this real quick. So I've gone ahead and edited these environment variables, and now I'm just going to go ahead and paste them into my PowerShell window and hit enter. And now all three of these should be set. So now when I go to run Terraform, it's going to look at the environment variables and be like, hey, I found an Amazon Web Services username and password and region. I will deploy all of these into that account. So with that set, we can begin to run our basic Terraform commands. So we're always going to start with a Terraform init. And this is going to download our AWS provider, but it's also going to download our PalWorld module from that registry. And then once that's initialized, ideally we want to run a Terraform plan, and that's going to tell us if everything's going to run properly and what's going to get created based on the inputs we've provided. So if we look through this list, and if you've never used Terraform and this looks like gibberish, some foreign language to you, essentially, Terraform creates resources like a network interface with an IP address, an AWS instance, which is the server, and it creates it based on the inputs we've given it. And then once Terraform finishes creating all of these resources, we will have these outputs potentially, such as our PalWorld server public IP, and Terraform will kind of spit that out for us when it's done applying. So we're going to create 11 resources. So now we're going to run a Terraform apply. Now when you run Terraform apply, it's going to run Terraform plan again, but this time it's going to ask you if you really want to do this. And you're going to have to type yes in order to do it. And so then we do that, and Terraform goes and it creates everything for us. It's creating our server, it's connecting everything. And then when it's done, we'll get some outputs such as our IP address. All right, so Terraform finished. It took all of 30 seconds to create all of that infrastructure. And now we have our IP address. So before we continue, let's go over to AWS and check out what got created. So in the AWS console, go up to the search bar in the top left and search for the EC2 service. And this is the service used to create those compute server instances. And we can see our PalWorld server is actually here. And it takes the server name as the name of the server. And we can see it's initializing, and then we can see some data about it, like the public IP address, but we already know that because Terraform output that for us. You can see under the security tab, right? What are we allowing traffic? We're only allowing traffic on port 22, so we can SSH in, and port 8211 for PalWorld. So now we're going to go ahead and connect to this server so I can show you what's going on in here. So we're going to do a command, and we're going to SSH in. We're going to use SSH-I, and then the name of the private key. So that would just be PalWorld. And then we do the username of the server that we want to SSH in as, and that would be Ubuntu and then the IP address. And yes. And we're probably going to get an error. Oh, we did not get an error. Okay. Sometimes you get an error about the permissions for PalWorld being the SSH key, the private key, being too open. If that happens, I will put a video on the screen right now and a link in the description to another YouTube video I have that helps you solve that issue. So then once you're in, you're going to be looking for the PalWorld server directory. So you're going to cd/palworld-server. I'm going to do an ls. And because I see all these files, that means PalWorld has finished installing. Now, if you don't see all these files in here, that just means PalWorld is still in the process of installing. It takes anywhere from 5 to 10 minutes for this process to fully complete. And once you're in the server, you can actually do journal ctl-xu cloud-final to view that install script. So if I hold space, I can scroll all the way down, right? And it shows me what's going on here, right? So if there's ever an issue or any errors, you should be able to troubleshoot it based on whatever's happening in this script. And then if we run system ctl status PalWorld, we can see if PalWorld is running or not. So it's green, it is active and running, and we can see this output here, which means PalWorld is running. It's up and running. We should be able to connect to it. And then the last thing we want to do while we're in here is we want to go into Pal. We want to look in saved, config, Linux server, and we want to make sure PalWorld settings, and we want to do cat PalWorld settings, just make sure some of the settings we set actually took effect. So, we're looking for daytime speed rate 3. That is what we set. EXP rate 4. Right? So we know our settings took effect. So let's go ahead and actually try to connect with PalWorld. So in PalWorld, you'll just join a multiplayer game like you normally would. You can attempt to search for that server name that you set. However, I have not been successful with this yet. I don't know why it doesn't show up. I think it's bugged. I have seen other people report the same problem. So we can connect down here with the IP address and port. So go ahead and grab that IP address of your server, and you can get that from the Terraform output, or you can go to the AWS console and click on the server, and it's in the details. And then just go ahead and paste that and the port number and hit connect. And assuming that you can connect and everything is up fine, which it should be, you'll be prompted to create a character. And there we go. I've connected and I've been prompted to create a character. So once you're done, you can go ahead and actually exit the SSH session so you're no longer in there. And if you determine you no longer need this server, you can simply run a Terraform destroy, and that will go ahead and destroy everything. It will completely wipe away everything. So you don't have to worry about having a server sitting around or an IP address or anything erroneous hanging out in your AWS account. And everything's gone, finished, finito. So if you like this video and you like this module, go ahead and head on over to GitHub, link in the description. Go ahead and star this repo if you'd like to contribute. I'm open to that as well. If you have any issues, go to the GitHub repo, click issues, go ahead and open an issue. If you hit new issue, you can open a feature request that you might have, a bug that you run into. You can even just ask a question. So if you stuck around to the end of the video, I did promise you some money saving tips when it came to using AWS. Now, the majority of your cost is going to come from the actual EC2 instance running itself. You know, you don't get charged when it's just sitting there off, but you do get charged when it's running. That's where the majority of our cost is coming from. So AWS actually has a calculator. I'll leave a link in the description, and we can estimate these costs real quick. So if we come to the estimator and we choose EC2 for our service, right, we know we need 4 cores and 16 gigs of memory. And so it doesn't really matter what we choose. Right now, I've shown you the example T3 extra large. If I do on demand, so I'm not using a cost savings plan, with 100% utilization, meaning I leave it running 24 hours a day, 7 days a week, it's going to cost me $121 a month. So roughly that $4 a day. And, you know, we can kind of play around with this. We can choose different servers, right? And the cost kind of goes up or down by a few dollars, but it doesn't change all that much. I think the cheapest would be the T4G extra large. And, you know, it goes down to $98 a month, but that's still pretty substantial. And then we can't use spot instances because we can't have our server just disappearing on us while we're using it. But what we can do is we can control the utilization of this server. So if I were to say move this down to 40% usage of the month, well, now that's a little more manageable, $40 a month. So if we break that down into hours a day, right? So maybe I only need to play 5 hours a day. I come home from work and I only leave the server on for 5 hours a day because that's how long me and my friends have to play, or maybe hours a week. So, you know, maybe on the weekends, me and my friends, we all just have a gaming binge and we play for 15 hours a day. So 30 hours a week, right? A lot more manageable. So one of the best ways we can save on costs here is just turning off the server when we're not using it. Now, I realize that doesn't work for everybody because sometimes you want your friends to be able to log in and you have different schedules. You know, when you're asleep, they want to play, vice versa. And in those instances, there's really nothing we can do about that. And that is when it would make more sense to probably go with a server hosting platform. But the main benefit of using your own AWS service is you get that maximum control. So the most efficient way to do this is if you know, or you have pretty consistent time frames, maybe you and your friends can only play 3 p.m. to Friday to 5 p.m. on Sunday, then you can set an auto schedule for these instances to stop after 5 p.m. on Sunday and start again on 3 p.m. on Friday. But if you'd rather just, you know, start it when you need it and stop it when you don't, I'm going to show you to do that manually real quick. You can go to the EC2 service and you can go to your PalWorld server or instance. You can click on it, and over here in the top right, you can hit stop instance. Now that will not destroy it. It will not destroy your server or your data. It will not hurt your PalWorld server. It will simply turn the computer off. And then when you're ready to start it again, you can instance state and start instance. Now, if you're interested in auto scheduling when these start and stop, you will go over to the CloudFormation service. And we will create what's called a stack. And we will keep template is ready and Amazon S3 URL as the default settings. And we will paste this URL link. And I'll put a link in the description to this URL as well. And we're going to hit next. And this stack is basically going to create a Lambda function that runs every now and then to look at all the instances and say which ones are tagged a specific way and do I need to turn them off or start them. So we'll give it a name. This will be EC2 auto start stop. Name it whatever you want. And for the parameters, the instance scheduler tag name. And this tag is how the auto start and stop function knows which servers to start and stop on which schedules. And we'll see that in a minute. But we'll just leave this as schedule. And then we'll leave all of this the same, but frequency, come down to frequency. This is how often the Lambda function is going to run to figure out if it needs to start or stop a server. Every time a Lambda function runs, it costs money, but it's fractions of a fraction of a cent. But it, we don't really need it to run every 5 minutes. So I'm just going to set that every 60 minutes. I'm going to leave everything else the same. By default, this will run in the US East 1 region. If you want it to run in a different region, provide your region here. And then I'm going to leave everything else the same and hit next. I'm not going to mess with any of this. I'm going to hit next again. I'm going to scroll down. I'm going to acknowledge, and I'm going to hit submit. So now you can see our stack is being created. And you'll see that CloudFormation is creating all of these resources that were in our stack. If we actually click on resources, we can see all the resources that are going to be created. And don't worry about pricing when it comes to this. A lot of this stuff is free, or it costs fractions of a fraction of a fraction of a penny, US dollars penny, when it runs. And I know it might look scary, but trust me when I say this is not where your costs are going to come from. It is going to be that instance running. So once your stack is created, you'll go up here in the top left to the DynamoDB service, because the DynamoDB table got created with this stack. If we go to tables, we can see our config table here. And then over here on the right, we're going to hit export table item. So in here we have schedules and we have periods, and a schedule correlates to a period. So when we tag an instance with our schedule key, we tell it which schedule in here we would like to use to start and stop our instance. So if we look at the example one, Seattle office hours schedule, if we were to set that as our tag value, then our period would be office hours. And then if we look at office hours period, we start or begin at 0900 and we stop at 1700. So we already have a period configured here, weekends. And if we look all the way over to the right, we can see that Saturday and Sunday are set. So if we only want our instances running on the weekend, we can click on the running schedule. We can go to add a new attribute. We will add a string set. We will add periods and then weekends. And we'll save and close. So then we can go to EC2, servers, and ideally you would do this as code with Terraform. Click on your server and then go to tags, hit manage tags on the right, add a new tag, and this one's going to be schedule, and the key will be running. Schedule, running, click on it, tags, schedule, running. It is case sensitive, so make sure these are lowercase, hit save, and now this server should only run on the weekend. All right, one last thing to go over, and we're going to set up a budget alert. So you can come up here to the top left search bar and you can search for billing, and you want billing and cost management. And under the budget and planning section on the left, you want to look for budgets. And then on the right here, you have the option to create a budget. And so you can use a template or you can customize it. We're just going to use a template for ease of use. And you can set up these different budgets, right? So a zero spend budget is basically if I am going to spend anything over $0, send me an email. Or you can do a monthly cost budget. So let's do that. You want to give your budget a name. So monthly allowance. You want to enter the budgeted amount. So if you're estimated to go over this amount, this is when we will send you an email. So if you've only got $50 a month to spend, if we think you're about to spend over $50 a month, we'll send you an email. And then you want to put the email address of the people or person that you want to receive this email when this budget's about to go over, right? And then you'll just hit create budget, and there you go. And you can create multiple budgets as well.